Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we are going to talk about actually my favorite part of algebra and actually one of the central parts of algebra. This is what we've been working so hard on. Okay? The reason you learn how to factor and complete the square, the zero product property, the quadratic formula, the quadratic inequalities, the reason we learned all of those skills is to apply it today. Graphing quadratic functions, okay? There are two ways to graph quadratic functions, actually three ways. There is the way that we're going to learn today using properties. Then there's a way to convert what we were given into what's called the vertex form of the quadratic formula, and I might show you how to graph that. And then there's yet another way that we're going to learn in a few chapters, and it's called the conic sections, and it's a third way to graph parabolas. What does that tell you? Parabolas are huge, okay? Parabolas are huge. What are parabolas? Well, parabolas come from quadratic functions, and we have already learned about quadratic functions. First of all, we know it's quadratic because x is squared, so that makes it quadratic. We know that a quadratic function is y equals ax squared plus bx plus c, or f of x, remember y is the same thing as f of x, equals ax squared plus bx plus c, where a is not equal to 0 and x is not equal to 0. What happens if a is equal to 0, guys? What happens to this? What does it become? Guys, if a is equal to 0, what? Thank you. It becomes a linear equation. What's 0 times x squared? 0. What am I left with? A linear equation. So a and x cannot be 0. If they are, we got problems. It's linear. The quadratic function produces a U-shaped graph. It's either going to be going upwards or downwards, but it is a U shape. And it is called a parabola. Okay? A parabola. It is the strongest structure that you can build. That's why most bridges, if you've noticed, or train tracks, are all parabolas, right? That's the way trains and a lot of bridges are made. The Roman aqueducts were all parabolas. The strongest arches in houses are under the arches of parabolas. Parabolas are huge. Huge. You see parabolas all the time. The golden arches of McDonald's, parabolas. Okay? There's a famous monument in St. Louis, which is also a huge parabola. Okay, so this is really, really important. Let's really investigate what every part of this is so you can really understand. Remember again that we're working with y, or f of x, equals ax squared plus bx plus c. All of these guys have a significance. Let's look at the a. Okay, the a is the coefficient of x squared. If a is greater than 0, if it's positive, then the graph will open upwards, just like you see right here. Period. It's that simple. If it's a positive number in front of x squared, you are going to be graphing a U-shaped graph that is pointing upwards. If you graph it and it's pointing downwards, I'm sorry, but you made a mistake. Period. Go back to the drawing board, do it again. If a is negative, though, okay, it will open downwards. If it's negative, just like in the diagram that I have right here, it will open downwards. Pretty simple so far, right? So if a is positive, it goes up. If a is negative, it goes down. This is a good test, because if you're graphing something and it's negative and the graph is pointing up, you messed up. Next, the c. The c is the constant, okay? The c is the constant. I have y equals ax squared plus bx plus c. The c is the y-intercept. Because when x is 0, bye-bye. When x is 0, bye-bye. When x is 0, y equals c. It is the y-intercept. It is the y value on the y-axis when x equals 0. You with me so far? Okay. Now, Parabolas are what's called symmetrical. I know that all of you know symmetry because of the following. Did you ever do when you were a little kid for like Mother's Day or for Valentine's Day, you know, you'd fold the paper in half and then you do one half of it like a little heart, right? And then when you cut it out and you unfolded it, you had the exact same half of the other heart on the other side. This heart that you created was cut down the middle by that fold that you did on the paper, right? Well, that fold or that line is called the axis of symmetry. Parabolas are symmetrical. Something symmetrical is something you can cut right down the middle, and when you overlap it, all points meet up together. Does that make sense? Okay. Kind of like your face. If you put a line directly in the middle of your face and you close your face on itself, your ears and everything will match up pretty much to the point, okay? Does that make sense? Okay, so the line that cuts a parabola into perfect symmetrical halves is called the axis of symmetry, which is an invisible vertical line found by using the formula negative b over 2a. So you take the value of the b, negative b, and divide it by 2 times the a value. When you get the axis of symmetry, like I said, it is an invisible line. So when we create the axis of symmetry, it's a dashed line. This line does not really exist. It is only here to help us graph. Because since the line is perfectly symmetrical, look how beautiful this works. I call these mirror image points. For example, this guy right here. Okay? This is 2 to the left from the axis of symmetry, right? Right? You have 1, 2, 3, 4, 5 little pieces. Well, now go 1, 2, 3, 4, 5 little pieces to the right. See how you have the exact same mirror image? Let's look at this point right here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little sections away. So to the right of it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections to the right of it, you have the mirror image again. That's the beauty of the axis of symmetry. It cuts it in perfect half and it lets you know, okay, if I have 1 point here on the left side, let me count how far away it was from the left or the right, and then go the opposite direction. Does that make sense? Works if it's going up or down. This is my axis of symmetry. So this guy right here, from the axis of symmetry, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little pieces away to the left. So go 1, 2, 3, 4, 5, 6, 7, 8. What did I do wrong here? Oh, because I doubled that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right from the axis of symmetry. They will always be like that. Once you have the axis of symmetry, it cuts it in perfect halves, and you can create what are called mirror image points. You with me? Okay. May I continue? Thank you. The vertex. Okay. Let me go back real quick. This point right here, the peak or the minimum, the trough, those are called the vertex. Okay, the vertex is, I like to call the swivel point. That's where the graph either starts going to the other side. That's the exact center of that graph. When I have a graph that's pointing upwards, my vertex is a minimum. Yes, sir?
It's just the minimum or the highest point, that point on the x, is that just the line of symmetry? Like
I have no idea what you said. I'm sorry.
The highest point of a parabola.
The highest point, like I just said, is the vertex if it's pointing downwards, and that's my maximum.
Yeah, but whatever the x point on that is, would that be on that line? Would that be the line of symmetry, the axis of symmetry?
Yes, the vertex is always on the axis of symmetry, and the x value of the axis of symmetry is the x value of the vertex. Yes, we're going to show that right now. But I wanted to give you a visual. Very good question, son. Thank you. So the vertex is either your highest maximum or your lowest minimum. And the axis of symmetry, the x value of the axis of symmetry is the same as the x value of the vertex. Very good. For example, the vertex of the parabola determines the maximum or the minimum values of the function, and is found by using the formula negative b over 2a. Wait a second, isn't that the formula for the axis of symmetry? So once you find the axis of symmetry value, you can plug it back into the function and then find the y value by plugging in the negative b over 2a. So once you find your axis of symmetry, you plug that x value into the function and you find the y value using that particular x. That will be your vertex. You with me here, guys? Okay. So simply plug in the value of the axis of symmetry, which is x equals negative b over 2a, into the quadratic function and solve for y. Okay? Remember, y is also known as f of x. Everyone with me so far? Okay. I forgot that I had drawn this so nicely for you. Okay, let's investigate this max and this minimum. If a is greater than 0, you know that the graph opens upwards. And since it opens upwards, my friends, you're going to have a vertex which is a minimum. Period. It's always going to be the same. When x is less than 0 and the graph is pointing downwards, there's going to be a maximum. Can be right up here. That will be my vertex when a is negative. So if the graph points up, a is positive, and you have a minimum. If the graph points down, it's negative, and you have a maximum. Does this make sense, guys? Okay. What does the graph of a quadratic function y equals ax squared plus bx plus c, aka also known as a parabola, look like? What are the significant parts of the parabola? Well, I got it all here for you guys. Why? Because I'm a boss. All right, let's check it out. We have this parabola. Okay, it's a U-shaped graph. It's pointing upwards. So what do we know about the A right off the bat? The A is positive. Since A is positive, my vertex, okay, my vertex, is that going to be a max or a min? Okay. How do I find my vertex? Well, I first find my axis of symmetry, which cuts that bad boy in half. How do I find that axis of symmetry? By using the formula x equals negative b over 2a. Remember, it's an x equals equation, my friends. An x equals equation is a vertical line. So that's why we have a vertical line going through that x value. Once I find that axis of symmetry value, I plug that value into the function and find my y value for that particular x. That will give me my vertex, which is right here. Is everyone with me so far? Then I can graph my y-intercept. My y-intercept is the y value on the y-axis when x equals 0. That's a parabola. The most basic form. But also, you know every part of it. Does that make sense? Okay, let's get to work then. How to graph a quadratic function. I made this very neat and organized for you. I want you to please simply follow directions. And you're going to see how easy this is. I want to graph 2x squared minus 8x plus 9. Right off the bat, does this have to point upwards or downwards? Okay, you don't need to write that down or anything, but you need to know in the back of your head, okay, this graph better be pointing upwards. That's the only reason why we know that, okay? If you don't know that and you graph it downwards, you're going to get it wrong. So make sure that that is going upwards. Okay, step 1, find the axis of symmetry. So negative b, negative times negative 8, over 2a, 2 times 2, that's 8 over 4. So x equals 2, And immediately I go to my x equals 2 and I draw a dashed line. I'm not even joking. This is exactly what I want to train you to do. Find the axis of symmetry, draw the axis of symmetry. Come on, my brothers, do it. Find the axis of symmetry, negative b over 2a, and then graph it, please. I don't want to bore you, but I don't want to go too fast. May I continue? Okay, guys. I'll do it in different colors, so it could be really easy to recognize. Step 2, find the vertex using negative b over 2a, comma, f of negative b over 2a. What does this mean, Mr. Morrow? My negative b over 2a I already found was 2, right? So I'm going to find f of 2. I'm just plugging in 2 into the function, right? So 2 times 2 squared is 4, minus 8 times 2 plus 9. I've got 8 minus 16, which is negative 8, plus 9 is 1. So my vertex equals 2, comma, 1. 2, comma 1. Correct? 8 minus 16 is negative 8. Negative 8 plus 9 is 1. Does that make sense, guys? I use the value of my negative b over 2a, and I plugged it in. I found f of my b over 2a, which in this case was 2. This should be like really easy, right? We've done these skills already, right, guys? That's why we wait for this time, because we've seen these skills already. So now I have my vertex. Graph it. Graph the vertex. Step 3. Find the y-intercept, which is the c value. It's the y value on the y-axis when x is 0. So what's the c value for this equation here? 9. So my y-intercept is, I'll do it in a different color, 0, comma 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 9. You with me? Right, guys? Mirror image. 1, 2 to the left, 1, 2 to the right, and guess what? We have a parabola. Does that make sense? Yes, sir. Yes, as long as you have the points, I'm not looking for an artist. I'm looking for the right values. Correct. Now, within reason. Some people like to do this, a V. I will mark that wrong. I will mark that wrong. Correct. Some people I've seen do this. That's a horseshoe, and that's not what I want. I will mark that wrong. I've seen some people who have really bad go like that. You know, try to work on that. But within reason, no, you don't have to be an artist. Now, step number 4. We did not need step number 4 for this one. And I'm going to explain to you why in a second. But step number 4 is very important. Step number 4 is extra point and its mirror image, or find the x-intercepts. Aren't those the solutions of the quadratic functions? Haven't we talked about that like at least 50 times? Right? That's when we factor, when we do the completing the square, when we do the quadratic formula. Are we finding the x value when y is 0? So find the x-intercepts, the roots, the zeros, either one, which is more accurate by either 1, locating it, or them on the graph. In this case, do I have any solutions? No. Or solving for x using the A, square root method, B, factoring, C, completing the square, or D, the quadratic formula. So in this particular case, I just asked you to graph. But eventually, I'm going to ask you to solve by graphing. So not only do you have to graph, but then you got to find the x-intercepts. So how would you find the x-intercepts? You either use the square root method, you either factor it, complete the square, or quadratic formula. Then you'll have your x values. You plug those and you connect everything nice and beautiful. We'll do an example like that now. But I need to explain to you that sometimes you're going to need step 4. If I just say graph, you don't need to find the exact x-intercepts. If I say solve by graphing, you do. Are you guys with me so far? Thank you, guys. Okay, let's graph. And actually, let's solve by graphing, okay? So you can really see what this is about. First of all, what do you think I got to do with this bad boy? Standard form, thank you. So x squared plus 8x plus 9. Step 1, axis of symmetry. It's negative b over 2a. So what would it be? Negative 8 over 2 times 1. So x equals negative 4. 1, 2, 3, negative 4. Put my axis of symmetry. Done. Vertex. Let's find the y value when x is negative 4. Negative 4 squared is 16 minus 32, which is negative 16. Negative 16 plus 9 is negative 7, right?
Yes.
Okay, so negative 4, 1, 2, 3, 4, 5, 6. Did I do that right? 1, 2, 3, 4, 5, 6, 7. That's my vertex. Is this going to be a minimum or a maximum? A minimum because the graph will point upward. Good. The y-intercept. What's my y value when x is 0? 9. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9. Can I do a mirror image? This is 1, 2, 3, 4 to the right. So my mirror image would be 1, 2, 3, 4 to the left. You with me, guys? Now, look. You could technically do that. But do you really know the x values? That's why you do step 4. Step 4, let's solve this bad boy. Let's do the extra point, or an x-intercept is needed. Extra point, let me explain that. You could go like this. For example, when x is negative 2, plug it in and find the y value. But that's not really going to find your x-intercepts. That's just going to help you make a prettier graph. But to really solve this, you need your x-intercepts. So I'm going to go ahead and factor this bad boy. We have x squared plus 8x. Oh, actually, we can't factor that, can we? No. Very good. Awesome. Even better. Awesome. What do we do when we can't factor? We can either complete the square or quadratic formula. What do you want to do? Okay, quadratic formula. Negative b plus or minus square root of b squared minus 4 times a times c over 2 times a. So that's negative 8 plus or minus 64 minus 36. That's 28. Am I right there, guys? 28. 28 is 4 times 7, right? So it's going to be 2 square root of 7 over 2. You guys with me here? So I've got negative 8 plus 2 square root of 7 over 2, comma, negative 8 minus 2 square root of 7 over 2. This is when calculators are useful. Yes, sir. Can I simplify this? Absolutely, 100%, and I thank you for bringing that up. This would be negative 4 plus square root of 7, or negative 4 minus square root of 7. Now, guys, let's find the values. We got negative 4, okay, plus the square root of 7, which would give us about negative 1.35, comma, negative 4 minus square root of 7 gives us negative 6.65. So these are my solutions. Hold on, let me finish and then you can ask me, okay? So negative 1.35 and negative 6.65. So negative 1.35 is like about here. And negative 6.65, 1, 2, 3, 4, 5, 6, it's like about here. And now You got a graph. Perfection. And when they ask you, well, what is that? Well, that's negative 1 point, what do we say? 1.35. And this is negative 6.65. That's solved and graphed perfection. Someone Mr. Morrowed me. How can I help you? Sorry. Yes, sir. If you don't simplify, it doesn't matter because you're going to put it into the calculator anyways, and it's going to give you the value. Sir. Okay, does that make sense though, guys? You promise? Yes, sir. They want you to solve by graphing. So they want you to find the y-intercept. They want you to find the vertex. They want you to find the axis of symmetry. But they want you to solve. So when you go ahead and just graph it, you don't know those points, do you? So how do you find those points? By solving. And you solve by either using the square root method, the quadratic formula, completing the square, factoring. Does that make sense, my brother? Yes, sir. If they just say only graph, you do not need step 4. Does it make it better, though? Yes. Is it difficult to find step 4? No, you guys have the skills for this, okay? Give me 1 second, guys, and we will continue. May I continue? Okay, how about this? Start this. I'm going to pause for 1 second. I'll be right back. All right, so now let's consider the function f of x equals x squared minus 4x plus 9. What do they tell you? Determine whether the function has a max or a min. What does this have right here? A minimum. See the power of knowing things, guys? How did you know it was a minimum? Because a is positive. If the coefficient in front of x squared is positive, it's going up, you have a minimum. If the coefficient of x squared is negative, it's going down, you have a maximum. State the maximum or the minimum value. So they want to find the vertex. How do I find the vertex? What's my first step? I find the axis. Go ahead, I'm listening. Negative b over 2a, good job. So what would the axis be here? 4 over 2, which is x equals 2, right? What do I do with that x equals 2 value? I plug it into the equation. So 2 squared is 4, minus 8 is negative 4, plus 5, plus 9 is 5. That is my minimum value. Powerful stuff here, guys. Powerful stuff. Proud of you, as always. Pretty easy, good. I like to hear that. Bless you, sir. Oh, and that's it? All right. Why don't we do this, because I got extra time. Why don't I show you something really pretty, just so you can see it. And then I'll show you something really ugly, just so you can see it, okay? Yeah, I mean difficult, yes. Okay, something pretty is like pretty numbers. Oh, wait a second. What if I were to tell you this? Well, actually, I got time. Let me do things the right way. Okay, let's see. Let's see. How about something like this? Okay. That's gonna be. Yeah, this is really easy. Okay, let me show you something. Okay, I want you to solve by graphing. Okay, solve by graphing. 1, my axis. My axis is negative b over 2a. So x equals negative 3. Done. Get my graph. I like to stay consistent. And as long as you stay consistent, that's how you really learn. So negative 3 for my axis. Done. 2, vertex. Vertex is my negative 3 plugged into here. So negative 3 squared is 9. 9 plus 6 times negative 3 is 9 minus 18, which is negative 9. Negative 9 plus 9 is 0. So negative 3, 0. Guess what? What is my vertex also in this case doubling as? It's the x-intercept, right? In this case, the vertex is the solution, right? Okay, check it out. Step 3, the y-intercept. What's the y-intercept when x is 0? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 1, 2, 3 to the right, so go 1, 2, 3 to the left. You already have your solution. You're done. What is my solution? Negative 3, comma 0. That is the x value when y is 0. In this particular case, your vertex happened to be the x-intercept. Sometimes it's going to be nice and pretty like that. Remember, there's 3 possibilities here. Bless you. You could have one solution, which, by the way, guys, if anyone remembers, isn't this an x plus 3 squared? Right? So remember, we did this back in the day. If we set it equal to 0, we square root both sides, and you got to go x plus 3 equals 0. X equals negative 3. See how it's all connecting? I hope. All right? So you have 3 possibilities. You can have one solution. You could have 2 solutions. Or it can be like this, you know, going that way. Or you can have no solution. Or up here like this. No solution means it never goes through the x-axis. Sir, my brother. How did I get the solution? The vertex is the solution in this case. In the other ones, there were 2 solutions. This was a perfect square binomial. Whenever you have a perfect square binomial, you're only going to have one intercept. Okay? Thank you, my man. Let's do something ugly. I'm just going to make it up. Let's show you what ugly is. 3x squared plus 2x minus 5. Okay, let's check. Actually, that is factorable. Actually, that is. But you know what? No, let's do it. Let's do it like this. Come on up. This is good. Okay, step 1, my axis. Negative b over 2a. So that's negative 1/3. Yeah, that's what I want. Something ugly. Okay. So you can see it doesn't matter. 1/3. Am I going to have to estimate the negative 1/3? Yeah, that's fine. So it's about here. Bless you. It's about there. 2, vertex. Vertex. Okay, negative 1/3. I got to plug negative 1/3 into here. I'm not going to do this in my head. 3 times negative 1/3 squared plus 2 times 1/3 minus 5. It's going to be negative 1/3 squared is 1/9. 3 times 1/9 is 1/3 plus 2/3 minus 5. 1/3 plus 2/3 is 3/3. That's 1. 1 minus 5 is negative 4. So right on the axis of symmetry, negative 1/3, comma, negative 4. 1, 2, 3, 4. What's my y-intercept? Step 3, what's my y-intercept? Negative 5. 0, comma, negative 5. So negative 1, 2, 3, 4, 5. Right here. Now, this is quite tricky. This is 1/3 to the right, correct? So go 1/3 to the left. It's still within the 1. Right? Wait, I did something wrong here. Huh? Wait, where? That's why, because that's a negative. I thought this was a little bit. Thank you. The y-intercept doesn't change, but this is garbage. Thank you. You know why I knew it was wrong? I was pointing downwards. Everyone makes mistakes. But if you know how it's supposed to look, you'll realize, oh, wait a second, I did something wrong. So that's a minus. So this is 1/3. This is 1/3 minus 2/3. Come on, Moro. Minus 5. So that's negative 1/3, so that's negative 5 1/3. That's my vertex. Negative 5 1/3. So let me get rid of this. So negative 5 1/3 would be 1, 2, 3, 4, 5, and a third. It's about right there, roughly. My y-intercept is 5. So that's 1/3 to the right, so go 1/3 to the left. Okay? And now, when I go ahead and graph that, it's going to be really inaccurate for the x-axis. That's why we can factor it. Step 4, let's factor this bad boy. It's a cubic method. 3x, 3x, negative 15. That's going to be positive 5. And negative 3, right? So I got 3x plus 5 and x minus 1 equals 0. So it's going to be negative 5/3 and 1, correct? So negative 5/3 and 1. Bam. That's my 1. And that's roughly negative 5/3. Not quite at the 2. Does that make sense, boys? That's ugly, and it's still doable. Sir? Okay, I'm waiting. Huh? Of course it's symmetrical. This point is 1/3 to the right. This is 1/3 to the left. How is it not symmetrical? This is 1 and a little piece to the right. This is 1 and a little piece to the left. It's still symmetrical, I promise. Thank you. Yes, sir. If the A was negative, it'd be pointing downwards. No. 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 The question was, can I factor out a negative from the beginning? Absolutely not. If you factor out a negative from the beginning, what happens? It's going to be pointing upwards. No. No. How many times do I say no? Do not do that. He's asking, can we do it and then flip it? No. You can, but it would be completely a waste of time. Okay? Please do not do that. If it's negative, use the negative A. Please. Thank you. Okay. And I got time for one more. How would I do? I'm going, sir. Thank you very much, though. I appreciate your awesomeness and your willingness to learn. Thank you. How about we graph? Let's just graph, not even solve, just graph. Negative y equals negative 4x squared minus 20x minus 25. Okay, let's see what we got. Okay, do not divide by a negative. Yes, sir. Come again? So what if it's factorable? I said graph it. But thank you. I appreciate it. I know it's factorable. In fact, it's a perfect square. It's a perfect square. But okay, but that's not what I asked. I asked to graph it. What is the axis of symmetry here, my brothers? Guys, negative b over 2a. So what is my axis of symmetry here, guys? 20 over negative 8. So let's reduce that. Negative 5/2. Correct? Equals my x-axis, right? Negative 5/2 is basically negative 2.5, right? So right here, my axis of symmetry. Now my vertex. My vertex is negative 5/2, comma the y value when I plug it in here. So this is negative 4 times negative 5/2 squared minus 20 times 5/2 minus 25. Huh? Yes, negative. Thank you. So I got negative 5 halves squared is 25 fourths times negative 4 would be,
one, no,
okay, let's do that again. This is 25 fourths times negative 4, so it would be, okay, let's try that again. We have negative 4 times 25 over 4. So what is that going to equal? Okay, what is it, guys? 25 or negative 25? Negative 25. Thank you. Good job, guys. Negative 20 times negative 5 halves.
negative 50.
Okay, some people are saying negative 50. Some people are saying positive 50. Positive 50 is correct. Thank you, my brothers. Minus 25. What's that going to equal?
0.
0. Very good. Negative 5 halves 0. Hey, guess what? What is that already in addition to being the vertex? It's also solution. Step 3, my y-intercept. What's my y-intercept? When x is 0, y is negative 25. So let's just go by intervals of 5 here. So 5, 10, 15, 20, 25. That is 2.5 to the left, I mean to the right. So I got to go 2.5 to the left. And guess what? That's my graph. Does that make sense, my brothers?
Yes, sir.
Okay. Thank you very much. Hope you learned a lot. Have a great day.